Hello, this is another video to progress in our math segment for the year. In this video, it talks about how relationships are proportional. In particular, we're going to talk about tables. So the first thing you need to know here is that there's an equation to find proportional relationships, and it's k equals y over x. And to make this a little simpler, all that equation represents is a unit rate. And we've done unit rates by doing a division problem. The y in this equation represents the dependent variable. And a dependent variable relies on the values of the independent variable. And you're going to see what that means here in a second, but the x is the independent variable. And the independent variable is the value that stands alone and no, I don't want $, relies on nothing else. So basically, nothing will affect the value of the independent variable. K K is the constant of proportionality. So if you think about this, let me zoom this out here. If this equation creates a unit rate, and K is the constant proportionality, another name for K is a unit rate. So really, K is just a constant proportionality / a unit rate. Proportional relationships from a table. We're going to just put this in here, and then you'll get the rest of it. The y over x values change at a constant rate for all values in the table. To find the constant rate change. I'm not going to write this word, but unit rate. You must divide, just like we did for finding unit rates. Now, for this table, I'm going to tell you that it is proportional. So what we're going to do here is we're going to find a constant rate of change because we need to fill in these two values. We don't know what they are. So let's just look at this. So we're going to do y over x. So in this case, y is, if we go back here, y is our dependent variable. And that means the number of words that someone types is dependent upon the amount of time. So if we're going to do that, obviously the more time you have, the more words you can type. So the words are dependent upon the time. So when we do that, we're going to write, just go to the first one here, and we're going to put 12 over 10. And if you do 12 divided by 10, you should get 1.2. And now we're going to check another value. So we're going to do 24 over 20. And if you do that one, you're going to get 1.2 again. So if we do 48 divided by 40, we should get 1.2, and we do. Now, we can check 120 divided by 100, and again we get 1.2. We don't know the value for 190, but if we do 258 divided by 215, we're also going to get 1.2. So in this case, this table has a constant change of 1.2. Now, we have to figure out the values that are missing. So we know that if we do 12 divided by 10, we get 1.2. So what could we multiply 10 by? 1.2 to get to 12. So in this case, we know that we have 50. So we're going to multiply that by 1.2, and you get 60. So you plug 60 in there, and you can check that by doing 60 divided by 50, and you get 1.2, so we know that that value is correct. So in this case, we just multiplied 50 by 1.2, but now we have 190, so we're going to work backwards. So we go 190 divided by 1.2, and we get 158.33. So our value that goes in here is 158.33. And we're going to write a statement down here to say why this table is proportional. So the table is proportional because there is a constant change for all values in the table, and 0, 0 is a coordinate. And what I mean by that is it's pretty simple. 0 minutes equals 0 words. Or in this case, 0 seconds equals 0 words. So in other words, if we were to go back here and we put in a 0 right here for time, we would have 0 words. So eventually this table would get to 0, 0 by doing our constant changes. So in conclusion, to determine if a table is proportional, it needs to have a constant change, or constant rate for all y over x values, which means it has a unit rate that's constant, and it should be able to have 0, 0. In this case, if you were to look at this table again and you go 10, 20, well, it goes by tens. The next number down would be 0, and it goes by 12s for the words, so the next number down would be 0. I do want to just fix one thing up here, if I may. I think I have to. Well, here's how I'm going to do it. This is a dependent variable. Sorry, it won't let me fix that. Again, if you have any questions about this, you may rewatch it as many times as you need to. Also, you could message me if you have any questions.